Okay, so this week we're going to focus on 10.1 and 10.2. Okay, both of those are in your book, but remember, if we started out last week, we're in chapter 5, we skipped 4 chapters. So you're going to have to, if you downloaded the whole book, you want to go skip all the way to chapter 10 for this week's stuff. And we're going to focus on solving systems of equations. So usually when you solve an equation in Algebra 1, you start out with solving a single equation for a single variable. Well, a system is when you're solving 2 or more equations for 2 or more variables. You generally solve for as many variables as they give you equations. So just as an example, here's a problem with 2 variables, x and y, and they gave you 2 equations, the top one and the bottom. So we'll be solving for x and y when we do that problem. Now you can solve for as many variables as you want. Depends on how many they give you. We're never going to have more than 3. We'll practice doing some 2 variable, then we'll get into some 3. But we're never going to look at like 4 or 5 variable or anything like that. One thing that is important is when you are solving a system, you need to make sure you give me the answer to each variable. So if there's 2 variables, and you only tell me one of them, well, you're already down at half credit. Okay, so you have to make sure you tell me both. All right, and let's just set up some equations for this one. We're not going to solve it. Excuse me. We're not going to solve it in this problem. We're going to solve it in the next one. So we're going to set up a problem that will allow us to find the length and the width of a rectangle. And the 2 pieces of information they tell us are the perimeter and the area. So in this case, you don't really have to figure out the formula from scratch. There already is a formula for perimeter, and there already is one for area. We just need to remember what they are. Okay, so think about, here's your rectangle. Just mark the length and the width. Can somebody tell me what would be the formula to find the perimeter of a rectangle? Yeah.
2 times length plus, right?
2 times length plus what?
The width.
That would add up 3 of the sides.
Oh, then it's plus 2.
2 width, yeah. So if you add up all these sides, you have an L and an L, so you get 2 of those. A W and a W, so 2 of those. So 2L plus 2W is your perimeter. And what's the formula for area of a rectangle? Yeah.
Length times width.
Length times width. So all we have to do to just set up the system, because we're going to be setting up a system with 2 equations, is fill in what they tell us. And that's it. Now this formula used L's and W's. Length and width, that makes sense for a rectangle. But a lot of times we'll use X and Y. All right, let's start with perimeter. Curtis, what's my perimeter here? 100. So this formula is going to turn into 100 equals 2L plus 2W. So there's your first equation. And Tony, what was my area? 300. So the area is 300. Okay, where you see area, fill in a 300, and that's it. And all they asked us to do was set up the system. We don't have to do anything else yet. Any questions on setting that up? Now, there's lots of numbers you can multiply together to get 300. You could do, 3 and 100. You could do 10 and 30. You could do 30 and 10. But the thing is, not only do they have to multiply to give you 300, they have to add up to give you 100. So that's what makes it a little harder to figure out. But as long as we follow method, then we don't have to guess what the answer is. So the two main ways that we're going to solve systems of equations are substitution and elimination. A third way that you can solve systems is graphing, okay, especially on the graphing calculator. You can calculate where two graphs cross. We're not going to spend a ton of time on graphing because we've done a lot with graphing already. And a fourth way that you can solve a system is called a matrix. We will do a matrix tomorrow. A matrix is it's a lot more organized when you start to get to like problems with 3, 4, 5 variables. We're not going to go that high, but we're going to go to 3. So it's more organized when you get to that many. But substitution is fine when you only have 2 variables. All right. So how do we do substitution? First thing you have to do is you're going to have 2 equations. You pick one of them. And in that equation, you get one of the letters by itself. So generally, at step 1, you have 4 options most of the time. I'll come right back to step 1. You can pick either the top or the bottom equation. And then, once you decide which one you want to work with, you can solve for either the x or the y. So you can solve the top for y, the top for x, the bottom for y, or the bottom for x. You have 4 choices. You can pick the easiest one. All right, let's try that. Let's do it as we do step 1. All right, so we want to pick one of those equations and we want to solve it for a variable. Which equation do you think is going to be easier to get a variable by itself? Top one or the bottom? Bottom. Yeah, if we pick the bottom one, we can do it in one step. So let's pick the bottom one. And now we have to choose, do we want to get the x by itself or the y? X. Okay, so that means we're going to put the y on the other side. If we get x, or how do we get x by itself? How do we move that y? Divide by what? Y. So we're going to divide by y on both sides. And what does that mean x is going to be? 300 over y. So that's step 1. Pick an equation and then get the variable by itself. Any question on step 1? Now step 2. You're going to take that and you're going to fill it in right there. So step 2 is to plug in what you just got in step 1 into the other equation. And when I say other equation, I mean the one you haven't used yet. So plug that into the top equation and simplify. So the goal in step 2 now is you are getting rid of one of your letters. If you do step 2 correctly, you're only going to have one letter in the problem. In our case, we're only going to have y's. So the first part is going to stay exactly the same. And now we're going to do 2 times, don't put x. Fill in what we got for x with the other formula. So 300 over y. Okay, so there's 2 times x. And that's still equal to 100. Okay, now you've got y in multiple spots, but that's okay. We only have y. We don't have x anymore. Okay, so let's finish this off. Let's finish solving this for y, and then I'll give you the last step, which is step 3. All right, so we got 2y plus, Austin, what's 2 times 300.
600.
So we've got 600 over y equals 100. Now, when you have something like that, you generally don't want to have a fraction. We have a fraction because we divided by y. How would you undo dividing by y? And we're going to have to do it here, here, and here. How could we get rid of dividing by y? Yeah.
Multiply by y.
Multiply by y. But you have to do it everywhere. So we're going to do times y, times y, times y. How about 1? What's 2y times y? 2y squared. Yep, good. So based on this highest exponent being a 2, you might be able to already guess what kind of equation we're going to end up with in a second. So 2y squared. Here, 600 times y divided by y. It cancels out. Equals. And Grady, what's on the other side?
100y.
100y. Since the highest exponent in that equation is a 2, what kind of equation is that? It's a quadratic. And what's one way that we can solve a quadratic equation? Yep, we can get it equal to 0. All right, so let's do that. Let's move the 100y to the other side. It's going to be minus 100y plus 600. And once we get it equal to 0, what's one method I could use to solve that quadratic? I could try to factor it, if factoring is going to work. Maybe. Or, if I can't, I can always, quadratic formula. But either way, there's something I could divide through first to make all my numbers a little smaller. You don't have to do this. But what could you divide through by to make all your numbers smaller? Yeah? 2. Right? So dividing through by 2 just makes everything a little smaller. Y squared minus 50y plus 300 equals 0. So if this is factorable, I'm trying to find two numbers that multiply to give me 300. And add to give me 50. Anybody think of two numbers that will multiply to give me 300? Add to give me 50. And you try like 60 and 5. That adds to give you 65. 30 and 10. 30 times 10 is 300, but that adds to give you 40. I don't think that's going to be factorable. So we're gonna try quadratic formula. Jenna, what are A, B, and C? It's the number in front of that. 1. B is negative 50. So yeah, we gotta make sure we have the negative with that. And C? 300. Okay. Let's go through quadratic formula. How about Abigail? What's the first thing we in quadratic formula? Do you remember? About Naisha, do you remember?
Like the first.
First step in quadratic.
So it's a, like, you want, like, the formula?
Yeah, first thing in the formula.
So it's b plus or minus, like,
There is a plus or minus, but careful. The first thing you said was b. It was close, but it's not b. You might remember what you do with the b? Yeah?
oh, negative.
Negative
It's
b.
negative b, sorry.
Yeah. So negative b, and then you said plus or minus, and
Yeah.
then let's write it down. What else is there?
The square root.
Yep.
Of.
B squared.
B squared.
What? Oh, b
Somebody
squared.
said it, yeah. Remember, yeah.
Is it minus 4 times A and C?
Minus 4 times a times c. And then that's all divided by,
Sorry.
close,
2 times A.
2 times a, which, yes, in this case would just be 2 times 1. Let's fill that in. So it's the opposite of b, so that's going to be 50 plus or minus the square root of negative 50 squared. That's negative 50 times negative 50. That's 2,500. Minus 4. A is 1. And C is 300. All over 2 times A, which is 2. Okay. What's 4 times 1 times 300? Yep.
Negative 1,200.
Yep, so that's going to be 2,500. And then you're going to have negative 1,200. That's what's going to be under the square root. What's 2,500 minus 1,200? Yep. 1,300. So 50 plus or minus square root of 1,300 over 2. And I know the square root of 1,300 doesn't have a nice answer. That's why we couldn't factor it. And not every problem ends up being a quadratic. Just this one did. A lot of times they don't. Okay, let's write down our 2 answers. So we have 50 plus the square root of 1,300 divided by 2. And that gives me 43.03, roughly. 43.03. What did we just solve for? Y. Y equals 43.03. Now, I didn't do the other one. 50 minus the square root of 1,300. And then divide by 2. Oops. Now I messed it up. 13.944448. Close enough. Take that and divide by 2. We get about 6.97. So you have to remember there were 2 answers for y. We haven't found x yet. X is going to be easy. But remember, a quadratic formula always gives you 2 answers. So let's call this one y1. Let's call this other one y2. Okay, because we were solving for y. We just have 2 answers. 6.97. Now, was there another letter that we still have to figure out? What do you think? Yeah? Yeah, we still had to find x. But now that we know y, well, x is easy. It's just x times the number we already have has to equal 300. So we could we can find y very easily. And that's step 3. Plug in the answer that we got from step 2. And where do you plug it back in? Doesn't matter. Just plug it back into one of the original equations. Pick the easiest one. And solve for the other variable. So Tyler, which equation here do you think is going to be easier to plug something back into? We can use either one. But you want to use the top one or the bottom one?
We do one.
Which one you want to do? The bottom one? Yeah, we could do the bottom one. I think the bottom one's easier because there's less going on. It's just multiplying 2 things together compared to multiplying 2 things, and adding. But either one will work. So let's use the bottom. X times y equals 300. Just going to copy that down so I remember what it is. We already took this equation and solved it for x earlier on. So you want to use the bottom equation. But what you really want to use is this. X equals 300 divided by y. So fill in what you got for y. 300 divided by that, and I'll get x. So we need to do that for each answer. Take 300 divided by y, and that will give you x. So let's take 300 and divide by 43.03. We just got 6.97. Does anybody have a guess what x2 is going to be?
43.04.
Yeah, it should come out the same. It might come out a little different because of rounding. But if you take 300 and divide by 6.97, you get almost the same thing, 43.04. And the reason those 2 answers are the same is because, remember, this problem was originally about a rectangle. There are 2 rectangles that could have the area and the perimeter that we said earlier. You could think of your rectangle like that, or you could think of your rectangle like that. Technically, it is a different number for the length than for the width. And those are your 2 answers. Any question on that? Usually doesn't end up being quadratic, okay, but that it can happen, especially in a word problem involving a rectangle. But I think that's the only rectangle word problem that we're going to do that's quadratic. All right, so how about Gavin? What was that method we just used? What was that called again?
Was it quadratic?
Well, we used the quadratic formula, but to solve the system, what was the method called? So it's not up there. It would have been on the last slide.
Mm-hmm.
Someone remind me, what was that method called that we just did? Substitution. So substitution is when you solve for one variable and you plug it into the other equation. What's the name of the other method I said we were going to try? Yep. Elimination. So let's do one more with substitution, and then I'll show you elimination. Okay, yes. Yeah. So let's do substitution. First, pick an equation and then pick the variable that you think is easiest to solve for. I think there is one variable here that's easier than all the others to get by itself. Yeah? So what are you trying, what is your goal here? In which equation? Yes. I would get y by itself in the top. And you said to subtract the 2x. And what do you get when you subtract 2x? Negative 2x plus 5. Yep. If you said 5 minus 2x, that's fine too. Okay. Now, what do I do with this negative 2x plus 5? Yep. Sorry, yes.
Check the 2x positive. Do anything.
No, whatever's in that box is fine.
Then when do you just get x alone?
Well, we have to do what the name of this method is. Yeah.
We plug y back in the other equation.
Right, we have to substitute that back in now. So you're going to take this. You don't make anything positive or negative, you just leave it the way it is. And you're just going to fill that back into the bottom equation. It's very important when you fill it in, you usually want to put parentheses. Because it's 2 times whatever you put in for y. So the entire y value is being doubled. It's going to be a distributive problem. So put parentheses. 2, and then fill in y. Negative 2x plus 5 equals 2. And now we'll solve it. Jackson, what would I do first to solve that?
You distribute 2.
Okay, let's do that. And can you tell me what you get?
Negative 4x plus 10.
It's 10. Equals 2. Good. Dominic, what would I do next? Sure, let's combine some like terms. What can we combine together?
The 3x and 4x.
Yep. And that'll give me negative x plus 10 equals 2. Let's see. How about Austin? What could I do next?
Subtract 10 and then make x positive.
Okay, so let's subtract 10 first. What's 2 minus 10?
Oh, 2 minus negative 8.
Negative 8. And then it's basically like we have a negative 1 right there. So we said we got to make that x positive. What do I do on both sides to get rid of this negative? You could multiply, but you don't want to multiply by a letter. It's going to be a number. Yeah? You could multiply or divide by negative 1. Either way. So let's just divide by negative 1. That cancels that out. Now we just have 1x equals 8. So x equals 8. Okay. We know x equals 8. What do we still have to do? Yeah? We still have to solve for y, but we've got a formula right here. Y equals negative 2x plus 5. So now, take this and plug it back in right there. So y equals negative 2x plus 5. And what we get for x, we got 8. Okay, let's do it out. Negative 2 times x. In this case, that's negative 2 times 8, which is negative 16 plus 5. And negative 16 plus 5 gives me negative 11. There you go. So x equals 8, y equals negative 11. You can write your answer in 2 separate boxes, or some people might do this. Because what that 8, negative 11 means, if you were to graph both of these on the calculator, that's where they would cross each other. 8, negative 11. So any questions on that? Okay, so that was another one with substitution. If you don't have directions on a problem, you can solve it any way you want. Substitution is generally a good thing to try when you have a letter that doesn't have a number in front of it except a 1. That's generally a good thing to try. A problem like this we're going to do, but we're not going to do substitution because it's not that easy to get x's or y's by themselves here without getting into fractions. So another method we can use is elimination. So elimination is when you basically add one equation to another equation. Sometimes you multiply it by something first before you add it. But the goal is to try to cancel out x's or y's. So like if I had something like 3x plus 6y equals 5, and let's say 12x minus y equals 1. Well, if I wanted to solve this with elimination, first I choose what variable I want to eliminate. Either the x's or the y's. To get the variable to eliminate, you want to make them opposites. So you want to have like a positive 6y up here and a negative 6y down here. So whatever you'd have to do to make this a negative 6y, you'd have to do it in all 3 spots. Or, if you don't want to get rid of the y's, you could try to get rid of the x's. The goal would be to have a 12x in the bottom and a negative 12x in the top. So you'd have to think, what do you multiply 3 by to make it negative 12? But you want them to be opposites. So then when you add them, you get 0. Now, if you multiply an equation by something before you add it to the other one, that's just called a linear combination. It just means it's a multiple. So like in this top one, I would say multiply it by negative 4. That's a linear combination. Why negative 4? Because it would make that negative 12, and it would make that positive 12. And then when you add them, negative 12 and positive 12 cancel out. But remember, whatever you do to one of them, if you multiply this first one by negative 4, you're going to multiply the second one by negative 4, and the third one. You're going to multiply them all. Again, the goal is to get the numbers in front of the variable to be opposite. Now, sometimes you might have equations that you could just add together and it just cancels out for you. Like 2x plus 3y equals 5, and negative 2x plus 6y equals 10. Well, if you just add those the way they are, positive 2x, negative 2x cancels out. You don't have to multiply by anything in that case. But sometimes you might have to. And elimination is what we're going to spend most of the rest of today on. Okay, we'll try an example with 2 variables. Maybe we'll do a couple. And then we'll try one with 3. Okay, so it's important to get 2 first, because then when you get to 3, 3's harder. Because you have more stuff going on. But let's try 2. All right, so Cameron, I'm going to let you pick. You want to try to make the x's cancel out or the y's?
The x's.
The x's. Okay, so we're gonna focus on this. So we need to make these numbers opposites. Well, one of them is a 2, and the other one is a negative 3. Can anybody think kind of what number we want to shoot for here? Like we'll have one here and the opposite of that here. Yeah.
You multiply top by 3 and the bottom by 2.
All right. Let's multiply. Let's do it like this. Let's multiply the top by 3, that entire thing. And you said multiply the bottom by what?
2.
2. So it's like a distributive property to everything. So 6x plus 9y equals 5 times 3 is 15. And now it's multiplied by 2. So basically the bottom equation is going to double. Can anyone tell me what's the bottom equation when you double everything? Yep. Negative 6x plus 10y equals 42. Perfect. Now, add them up. You've got to make sure your x's are in a column and your y's are in a column. But they already were here. Okay. Ryan, what's 6x and negative 6x?
0x.
0x. That's gone. Now add the next column. What's 9y and 10y?
Negative 1y.
Positive 9 and positive
Oh,
10.
19y.
Yeah. And positive 15 and positive 42. 57. Yep. And Sam, what would my last step be?
Your last step would be getting y by itself, which would be 5 by 19 on each side.
Divide by 19. And what's 57 divided by 19? 3. So let's put that over here. Y equals 3. Grady, what do I still have to solve for?
For x.
Yep, I still need x. And you can pick, you want to plug the 3 back into the top or the bottom.
Oh, the top.
Yeah, I would plug it into the top because the numbers there are smaller. They're also positive. So let's take what we got for y and fill it in for y. If you found y correctly, it doesn't matter which equation you pick. Well, let's do the top. So 2x plus, Tony, what's 3 times 3? 9 equals 5. Notice I'm not using the version that I tripled. Why use the version that has bigger numbers? Just go back to the original. It had smaller numbers. So 2x plus 9 equals 5. Curtis, what would I do next?
Subtract 9 equals 5.
Okay. And 5 minus 9 is going to give me negative 4. Divide by 2. X equals negative 2. Any questions on that? You definitely could have used substitution on this one, but to get the x or the y by itself, you would have had fractions to deal with throughout the problem. If you did it right, you still would have gotten the same answer. But doing it this way, we didn't have any fractions. I'm not going to say you can always avoid fractions. There will be some problems with fractions. All right, so there's 3 different things that can happen when we are solving a system with 2 variables. You guys have already seen this case. You get one answer for x, one answer for y. I think in the elimination problem it was the same, or the substitution, same thing. One answer for x, one answer for y. So that's an example of a one solution. If you were to draw or graph problems that we just did, they would look something like this. They would have 2 lines and they would cross in one spot. What else could happen if you draw 2 lines besides crossing in one spot? Yep. They could be the exact same line, so they could be right on top of each other. Yep. And what would that look like if you drew them?
Parallel.
They look parallel. So this is really the three things that can happen with lines. The first problem we did with the quadratic equation, that wasn't a line. Quadratics are lines. Those are problems. But the last two we did were linear problems. So they cross in one spot. They're parallel to each other, so they don't cross at all. Or they're basically the exact same line. So there's infinite solutions because you're just drawing two lines right on top of each other. So let's try an example where we have to solve, and I want you to see what happens when it's a no solution or infinite solutions. You already know what happens here. We did two of those. Let's try one of the others. Okay. So we have 2x minus 3y equals 5, and negative 6x plus 9y equals 10. Which method do you think this is set up for? Which method do you think it's set up for to be easier? Substitution or elimination? Yeah?
Substitution. And sorry, elimination.
Yeah, it's definitely elimination because all you have to do is multiply the top equation by a certain number. And it's going to help you work with the bottom. What could we multiply the top by? You don't have to do anything to the bottom this time. Yep. 3. So let's multiply everything by 3. So essentially triple the top equation. 6x minus 9y equals 15. Negative 6x plus 9y equals 10. What's 6x and negative 6x? 0. That's gone. So we have 0. What's negative 9y plus 9y? So now the whole left-hand side is 0. And what's 15 plus 10? Okay, at this point, we're done. When all the letters are gone, there's nothing else for you to do except look at that and say whether it's true or false in your head. And that's either going to mean no solution or infinite solution. So what do you think this problem is? This is a no solution. This is no solution because 0 does not equal 25. 0 does not equal 25. That's a no solution. So when all your letters disappear, it's either no solution or infinite solution. Any question on that? Let's try one more with 2 variables, and then we're going to finish up with 3. Three's a little harder. Okay, but let's do one more with 2. All right, let's try elimination. And does anyone see what I could multiply the top equation by? Yeah, let's multiply everything by 2. And Sky, what does that give me if I double everything in the top? It's negative 4. The bottom one stays the same. So just line that up underneath. Forgot my negative. And add everything up. What's 2x plus negative 2x? Gone. Negative 6y plus 6y. So the entire left side is 0. And negative 4 plus 4. 0. So this time we ended up with something that is true. 0 does equal 0. So what do you think the answer is here? Infinite solutions. Good. So basically, if you graph these on the calculator, they're the exact same line. They're right on top of each other. Same slope, same y-intercept. So that's the 2 special cases that can happen with 2 solutions. Any questions before we finish up with a 3 variable? So you might think, well, you just go from 2 to 3. It's only one more variable. But to solve it with elimination, it ends up being a lot more steps. Okay? Because there's There's just more things happening. So I can write down what to do, like I did before. It's going to be a lot easier to just see a problem. But the goal is going to be to take our problem that has 3 variables and turn it into a problem with 2. Then, once we turn it into a problem with 2, we can do it just like we did a minute ago. But we've got to get rid of a variable first. The 3 letters you'll generally see are X, Y, and Z. And the goal is going to be to eliminate one of those letters twice. Which letter? You can pick any letter you want, whatever one looks easiest. Pick a letter, and we're going to eliminate that letter twice in 2 of the equations. Once you've done that, after this first step, you're going to be down to a problem with 2 variables and 2 equations. Now, solve that like I just taught you. Eliminate another variable. Now you're going to be down to 1 variable with 1 equation. And you're going to solve for that variable. Once you get 1 variable, then it's easy. You use substitution and you start plugging it back in. But that's generally the 2 steps. It's pretty easy to describe it. It's a little harder to do it, especially if you start getting fractions involved. Then the arithmetic just starts getting complicated. So we're gonna try to do one where fractions are not involved for the first one. The other thing that happens with this is because each step kind of builds you to the next one, if you make a mistake on a step early on, it will mess up every step after that. So we just have to be careful. So there's our system. Okay, we'll definitely get through that one. If we have time, I have one more. And that was the last. That's the last one. Yeah.
Could you go back to the other slide?
Yep. So I try not to make my z's look like 2's, otherwise that gets even more confusing. So on the other page it says 2x plus 3y minus z equals -1. 3x minus 2y plus 2z equals 15. And x plus 4y minus 3z equals -8. I'm going to number those equations. So just I have names for them. Anytime I put a number and circle it, that means equation number. Okay, that's what that stands for. So this is equation number 1, equation number 2, and equation number 3. Does everybody have the left side? Yeah. So you have 9, well, yeah, I guess you have lots of choices here. The goal now is to pick an equation and use that equation to eliminate a variable in the other 2. What I would look for is look for an equation that has a variable without a number in front of it. That's going to be the easiest one to use to help me. Is there an equation here that doesn't have a number in front of it except for a 1? A 1 is open. Yeah? Yes. So we definitely want to use equation 3. And now you have to pick another equation, because every step you're always working with 2 equations. Let's pick equations 1 and 3. Let's use those 2. What variable do you think we could eliminate pretty easily in equations 1 and 3 by multiplying equation 3 by something. What variable? Yeah, we can get rid of the x's. So I'm just going to write that here. Eliminate the x values. So let's copy. This is why it takes a little bit of time, because I'm going to copy everything down each time. So let's copy equation 1. If I make a mistake, let me know. And equation 3. Okay. And now let's do what we did before. We're going to multiply one of these equations by something, but we're trying to eliminate x's. So this is a 2. I would make this bottom one the opposite. So what would I multiply everything in that bottom equation by? And then the x's would be gone. Yep. Negative 2. Okay, because I'm going to add things up in columns, I want my other equation on the top back over here. So I'm going to just write it down. 2x plus 3y minus z equals negative 1. And now multiply everything in the bottom by negative 2. So there are 4 things you need to multiply. Jackson, what's negative 2 times x?
Negative 2x.
Good. And Dustin, what's negative 2 times 4y?
Negative AY.
Negative ay. I don't really care what happens to the y's and the z's. All I know is I wanted the x's gone, and that's going to happen. Jenna, what's negative 2 times negative 3z? 6z. And Sam, what's negative 2 times negative 8? 16. Okay, add them up. Abigail, what's 2x and negative 2x? 0. That's gone. Okay, Ryan, 3y and negative 8y?
Oh, 5y. Oh, negative 5y.
Negative 5y. Gavin, negative 6z plus 6z?
That would be 5z.
5z. And Curtis, what's negative 1 plus 16? 15. Now, something special happened here that doesn't always happen, but all those numbers are divisible by what? By 5. So if you want to divide them by 5 to make that equation simpler, you can. That usually does not happen. So let's divide everything by 5. Negative y plus z equals 3. I'm going to call that equation 4. What I just did is, using equations 1 and 3, I created a new equation that doesn't have an x in it. Now, I need one more equation without an x in it. And then I'll have 2 equations with 2 variables that I can solve just like I showed you. So you have to get rid of the x again. But you already did equations 1 and 3. What 2 equations do you think I want to pick this time?
2 and 3.
I would do 2 and 3. So now, let's do 2 and 3. And we're going to eliminate the x again. Okay, let me copy them down. So 3x minus 2y plus 2z equals 15. And equation 3, x plus 4y minus 3z equals, what does it equal? Negative 8. So you might think, well, what are we doing with equation 4? For now, nothing. We're going to keep it right there. We're going to use it. But I need another equation that only has 2 letters first. And then I'll come back to equation 4. Okay. So what could I do to eliminate the x's in this equation? Multiply the bottom by negative 3. So distribute that up. Okay, top stays the same. 3x negative 2y 2z equals 15. And Caleb, can you tell me when I multiply everything by negative 3, what I get in the bottom? Is that the second time I've done that? I'm sorry. I'm going to blame the Caleb that sits there in the class before you. I want to multiply everything in the bottom by negative 3. So negative 3x. And then what's negative 3 times 4y? Negative 12y. Negative 3 times negative 3z. 9z. And negative 3 times negative 8. 24. Good job, Alex. And I'll tell you what, if you want to call me by the other Mr. Hager, you can call me Mr. Hager instead. Okay, so now we add these up. Negative 3x, positive 3x, those are going to cancel out. So we got that. Now we're going to add up the y's and the z's, and that's going to give me equation number 5. What's negative 2x and negative 12y? Okay. 2z and 9z, 11z, and 15 plus 24, 39. Okay, not that I think we did anything wrong. Those are just kind of some big numbers there. So I'm just going to double check, make sure we did everything right. So 3x minus 2y plus 2z, that looks good. Negative 3x minus 12y plus 7z plus 24. That's gone. Negative 14. All right, and I think we did everything right. And that is equation 5. Now, we're finally down to a problem like I started you with 2 problems ago. We have 2 equations, and we have 2 variables. So now, let's use equations 4 and 5. And this is the step where now we're finally going to start getting an answer for either y or z. Okay, so you get to pick. Do you want to try to eliminate, looking at equations 4 and 5, do you want to try to eliminate the y's or the z's? The z's? Okay, so we could try to do that. At least we have a 1 in front of that z, so that's good. So lots of choices here. So eliminate z. Again, for me, I like it all together, so I'm going to copy them down again. So negative y plus z equals 3. Negative 14y plus 11z equals 39. All right. So we're going to eliminate z. Anybody see what we would multiply by?
Negative 11.
Yep, negative 11. Now I told you, most of the time with a problem like this, I'm going to make the answers come out to nice numbers. So if you start getting lots of decimals, take a step back and see if you made a mistake. So let's multiply by negative 11. Abigail, what's negative 11 times negative y? 11y. And negative 11 times z, Naija?
Negative 11 times z is negative 11z.
Negative 11z. And Tyler, negative 11 times 3? Negative 33. Copy it over again. Half of this is just copying something you already have. Negative 14y plus 11z equals 39. Actually, yeah, I like this. It's going to work out. It's going to work out good. What's negative 11y and positive 11y and negative 14y? Yeah. Negative 3y. Negative 11z and positive 11z. Gone. And what's negative 33 plus 39? 6. Perfect. Now we're at the step where we can finally get one of our answers. And from here, all the other ones are going to come pretty quick. How do we get y by itself there? Yep, divide by negative 3. Negative 3. Okay, so first letter we just solved for is y. What is it? Negative 2. Now, work your way back with use substitution. I would use equation 4 to now solve for z. Negative y plus z equals 3. Let's just copy that here. What was it again? 3. So z comes out to, you said 5?
Yeah. So then -2 plus 4 equals 3. That's 5.
Remember though, when you plug it in there, it's going to be negative 2.
So that's 1.
So negative 2. So that's 2 plus z equals 3. So then z equals, what did you say?
1.
Yep. Any questions how Dustin got 1 for that? Okay, so now we just have to go back and find x. So go back to one of the original problems. We can pick either equation. Let's say, I don't know, you want to do the third one? Okay, so the third one already has x as just a 1, so that's kind of nice. So x plus 4y minus 3z. X plus 4y minus 3z. What was that equal to? Negative 8. X, we don't know. What do we get for y?
Y, -2.
Negative 2. Z I still have on the screen. Okay, 4 times negative 2. Negative 8. Minus 3 times 1. Well, that's 3. What's negative 8 minus 3? Negative 11. Add 11. And negative 8 plus 11? 3. There you go. So, x is 3, y is negative 2, z is 1. On a test, most likely it will be set up with boxes that you just put your answer into. Just make sure you put the right answer in the right box. Yeah.
What equation did you substitute y into the z?
What equation did I substitute y into? Negative y plus z equals 3. That was equation 4.
Okay.
So you really end up making 5 equations. Well, you get 3 originals. You make 2 that only have 2 variables. And then you solve that for one of the variables. And then you substitute back. Alright, so 3 variables, it has a lot more steps. But it's just the same steps for 2 variables over and over. And I do a lot of copying. So half my writing is probably just copying. Any question on that? So, the one downside, let me just zoom way out on this. So, the downside to this kind of problem is there was a lot of writing. And half the writing I did here was copying, first of all. And the second thing was I had to keep writing x, y's, and z's a lot. If you count up all the x, y's, and z's, that probably makes up maybe a third of everything I wrote down, just writing letters. Well, there is a more efficient way to write things down, especially when you get into 3 variables, because the writing starts to be a lot. So we want a better way to write things down. And that's more of what we're going to get into for the rest of this week. Okay, what's called a matrix. Matrices is the plural of a matrix. And this problem can be represented a lot shorter. The way you can write something down with a matrix is all you have to do is copy down the numbers that are in front of the letters. And then we understand that this first column is always x values. The second column is always y values. And the third column, we separate it with a line because that represents the other side. The third column is the numbers on the other side of your equation. So if you look at how many things I had to write here, 1, 2, 3, 4, 5, 6, and if you count the vertical line, that was 7. And then if you look at everything individually here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it was basically, if you count each individual number and letter, it was half the amount of writing that I just did. Doesn't seem like it saves much, but when you get into a problem like we did last time, if you could cut the amount of writing down for this problem in half, well, that would be a lot less, right? So that's called a matrix. And we'll do more with a matrix tomorrow. The other nice thing about a matrix is it eliminates having to guess. Like, wait, do you want to pick the first equation and the second equation, and do you want to get rid of x? Or do you want to use the first one and the third one and get rid of y? With a matrix, there's no guessing. You do exactly the same thing every single time. So if you're kind of confused about which direction to go in, a matrix eliminates all those choices for you. You don't have any choices. Question, Dustin?
So we're gonna be doing matrices on these tests, right?
Yeah, tomorrow we're gonna learn. Yep.
So on the test, we get our answer through the calculator. Can we use that, or do we have to write out all of our answers?
So when you're solving a system, you still have to show me work. Yeah. Because I know how you can just do it automatically.
Yeah, no.
Yeah, you can check your answer with that. But yeah, you still have to show me like the steps. So for this one, this is a test where, because the calculator could just do it for you, I would probably collect your scrap work to see how you did it. Is there any question on that? Okay. All right, so let me double check that, 541. I think it's okay. Yeah, I think that's good. Try that. 1 through 19, just the odds. Okay, just odds.